In this question, it is given that let f takes the open interval 0 to 1 to R be a function defined by fx equal to this and gx equal to this. Consider two statements where g is an increasing function in the interval 0 to 1, g is 1 1 in the interval 0 to 1. You have to find the correct choice. First of all, with the help of fx, we will find the value of f minus x. Clearly, f minus x is equal to 1 upon 1 minus e power minus of minus x, that is 1 upon 1 minus e to power x, and fx is already 1 upon 1 minus e to power minus x, that is e to power x upon e to power x minus 1. Hence, gx is equal to this minus this, that is 1 upon 1 minus e to power x minus e to power x upon e to power x minus 1, that is 1 plus e to power x upon 1 minus e to power x. Hence, g dash x is equal to 1 minus e to power x whole square into 1 minus e to power x into e to power x minus 1 plus e to power x into minus e to power x. This is equal to 2 e to power x upon e to power x minus 1 whole square, which is clearly positive for every value of x. Hence, in the interval 0 to 1 also. Therefore, g is an increasing function in the interval 0 to 1 is correct. And while studying functions, you must have studied this thing. A continuous function which is always increasing is sure to be 1 1. And it is clear that in the interval 0 to 1 it is continuous function, and increasing also we have proved it, and a function which is continuous and increasing is sure to be 1 1. Hence, I can say first and second both are correct. Therefore, fourth choice becomes the correct choice. In this question, it is given that the distance of the point P from the line passing through the point this and parallel to a line with direction ratios 3, 3 and minus 1 is equal to, you have to find the correct choice. According to question, this is a line having direction ratio 3, 3 and minus 1, and this line is passing through the point minus 3, 2 and 3, and there is a point P coordinates 4, 6, minus 2. You have to find the distance of this point from this line, that is, distance means perpendicular distance you have to find. These are direction ratios. One way of doing this question is find this point and then using distance formula find this distance. Or the second way is find this distance, say this point is Q. Find the distance between P and Q, and after that find the projection of PQ on this line. You will be getting this length, and after using Pythagoras theorem you can get this distance. Let me do this question by both the ways. In the first way, first I will find the distance PQ, and after that I will be finding the length of projections. See, this point is R. It is equal to under root 7 square plus 4 square plus 5 square. This is equal to under root 90, that is 3 under root 10. And the length QR is equal to, for this first we will have to find the direction cosines of this line. That will be 3 by under root 19, 3 by under root 19 and minus 1 by under root 19. And we know that if this is the point x1 y1 z1, this is the point x2 y2 z2, and this is the line having direction cosines L, M and N. It is A and it is B. The distance AB is equal to L into x2 minus x1 plus M into y2 minus y1 plus N into z2 minus z1. This is the formula for finding the length of projection of a line segment on a line having direction cosines LMN. Hence, using this formula, QR will be equal to 3 by under root 19 into x2 minus x1, that is 7, plus 3 by under root 19 into y2 minus y1, that is 4, plus c by, that is minus 1 by under root 19 into minus 5. This is equal to mod of 21 plus 12 plus 5 by under root 19. This is equal to 38 upon under root 19, that is 2 under root 19. Hence, we conclude that the distance PR, PQ square minus QR square. PQ square is 90 minus QR is 2 under root 19, and therefore using Pythagoras theorem, PR square is equal to PQ square minus QR square, PQ square minus QR square, and PQ square is 90 minus QR square is 76. This is equal to 14. Hence, I can say PR is equal to under root 14. Hence, I can say fourth choice is correct. As it is given that the line is passing to the point minus 3, 2, 3, and direction ratio of this line are 3, 3, minus 1. And P is the point 4, 6, minus 2. We have to find the perpendicular distance of the point P from this line. First of all, I find the equation of this line. You must be knowing that the equation of this line in symmetrical form is x plus 3 upon 3, y minus 2 upon 3, z minus 3 upon minus 1. For finding the point, say A, we know that we use the steps let it be equal to R. I get x equal to 3R minus 3, y equal to 3R plus 2, z equal to minus R plus 3. Because for every point on this line, there are different values of R. I will find the value of R such that this point becomes the coordinate of the point A. And if these are the coordinates of the point A, then direction ratio of PA will be 3R minus 3 minus 4, 3R plus 2 minus 6, and minus R plus 3 plus 2. That is using the formula that direction ratio of APR x2 minus x1, y2 minus y1, and z2 minus z1. And because PA and the line are perpendicular, hence using the condition of perpendicularity, I will get 3R minus 7 into 3. plus y2 minus y1, that is this 3r minus 4 into 3 plus minus r plus 3, that is z2 minus z1 into minus 1 equal to 0. This implies that 19r minus 38 equal 0, that is the value of r is 2. Hence, using these formulas, and because these coordinates were coordinates of the point A and we have got the value of r as 2, hence I can say A equal to 3, 8 and 1. Hence the distance AP equal to under root, we have got the point A as 3, 8, 1. AP is equal to 4 minus 3 whole square plus 6 minus 8 whole square plus minus 2 minus 1 whole square. This is equal to under root 1 plus 4 plus 9, that is equal to under root 14. Hence I can say fourth choice is correct.